Hi again, and in this lecture we will talk about the components on the printed circuit board. Yeah, at least you should know what you are working with, and you should recognize the component when you see it on a PCB, and you should know which type of components you can take. So we'll go briefly through all the different types of components you can use in order to make an electronic circuit. Okay. First of all, you should know that we have, of course you know that we have through-hole technology and we have surface-mounted technology. But also you should know that there are several, I would say, abbreviations used in this area. So at least you should know what they mean. Printed circuit board, printed wiring board. This is the same thing, but two different names. Printed board assembly process. Then we have technology, assembly, and devices. So these are all devices we'll talk today. In the through-hole area, we have radial components which have leads or terminals from the same side, from single side, like capacitors. We have axial components which have terminals from both sides, on the opposite side, like diodes, resistors. And we have dual inline integrated circuits, which are nowadays quite rare. Then we have small outline transistors, small outline integrated circuits. We have chip components. Chip is actually not an integrated circuit. Chip means a small piece of square type, of square shape. We have array components, and that's it. They can be both sided, top and bottom. This is how the technologies emerge through the history, starting with through-hole, then in 80s and 90s, surface-mounted start to prevail, and in this century now, the array components are taking place, and starting with 3D and stacked on top of each other. So let's go now through a little bit what type of components are and what they are used for. Starting with through-hole devices, they are used for three main purposes. For mechanical strength, because the components are very large, they need through-holes to be stable and not to fall off after a certain time of use. Large dynamic forces like connectors, when you pull the wire, it shouldn't drop off. And large currents and large power. These are axial components, radial, and dual inline, as I said, integrated circuits. However, these dual inline are really rarely used nowadays. This is an example of a USB connector, which is an SMT with some extra pins for mechanical strength. So still part of it is through-hole, because otherwise you can just peel it off when you pull the USB cable. Through-hole resistors are marked with colors, and you should know what these colors mean. So these are the colors associated with the numbers, and here you go. First color, first number, second number, and the third or the last in this row, they can be four as well. The last in this row is the exponent. So 1, 2, 10 times 2. So 1, 2, and 2 zeros. So 1.2 kilo ohms. Let's go to maybe that one. This is orange, so 3, white, 9 times 10 to 0. So 39 ohms, not 390. And the last color is the tolerance. In case of gold, is 5%. Through-hole capacitors, we have ceramic, we have electrolytic, and film capacitors. Ceramic capacitors are the most quality ones, but they have lower values. Their values are stated in picofarads. So 10 times 10 to 3, it is 10,000 picofarads or 10 nano. This is 20 times 10 to 2, which means 2,000 picofarads or 2 nanofarads. Here, in the electrolytic capacitors where the values are much higher, they are stated in microfarads, 47 micro, let's say. and the nominal voltage. They are polarized, so the minus terminal is marked with a dash here, or a line, or some sign that is denoting the minus terminal. The film capacitors are still quite used nowadays for filtering purposes, because they're very good. Values are in picofarads. The nominal voltage is for AC current here, or AC voltage here, because they are used for mains power supply filtering, and this is the safety standard, for example X2. We will have a lecture about that sometime later. Okay. Dual inline ICs are not very common anymore now, so I will just skip it. Somewhere you can still see single inline packages for some high power amplifiers, maybe some resistor arrays, modules, relays, and so on. Through-hole packages are for transistors, mostly used, I would say the TO222 and 237 are still available. The small ones are now more or less obsolete, and TO3 for high power transistor as well. So that one and that one. They are mounted on heatsinks or directly to the PCB. The high power IC packages can be also found in through-hole housings when their name resembles the number of connectors, of pins, pentawatt, heptawatt, and more than 10 you would find multiwatt. And what you usually find are some power amplifiers in that, or some motor drivers or stuff like that. Going to the passive components, SMT passive components are resistor, diodes, LEDs in this case, capacitors, and coils. Resistors are the most common, and capacitors as well. And resistor at least are still marked with some values. 1000 is 100 ohms, because the last letter is the exponent or number of zeros. So 100 and number of zeros is 0, so that 0 doesn't exist. This is 1 kilo ohm, and this is something completely unknown, and you have to check it out on the website. Smaller are not marked anymore because you can't see it. The capacitors are usually of such a shape, more the height is larger. They are more of rectangular, square-like shape, and coil even more, and they are usually black. The LED diodes have marked the forward current direction, so this is the anode and this is the cathode, so the current flows like that. And here also you see this marking here. Okay, going further. Sorry, about the size marking. Yeah, that's important. Sorry. The size marking. The values here are in tens of mils, which means 0805 means 80 times 50 mils, or 2.2 times 1.2 millimeters, and so on. So these size markings are standardized and they're used worldwide. So the most common markings nowadays are common sizes we use in everyday life for hobby or prototyping is 0805, 0603. Even 0402 are also can be soldered manually. Below that, forget it. So these are I would say now mainstream is 0603 for us, because it's still easy to solder and it's small enough to be able to work with it and to make some small nice PCBs out of it. The marking on resistors again is the same way. So we have 47 times to 10 to 1, so 470, and so on and so on. Here the letter is denoting the exponent and also the decimal point place, so 0.47 mega ohms in this case. These are ambiguous. 470, it's not 470 ohms, but 47. And what about these here? Well, these are 0 ohm jumpers. In order to, we use them to cross some line on a single side, or to connect two parts of PCB together. And different number of 0 means different level of short circuit. So it's like non-alcoholic beer. If it's 0%, it could go up to 0.5% actually. So this means less than 0.5 ohms, less than 0.05 ohms, and so on. Okay, this is the solution. The surface-mounted tantalum capacitors are a special type of electrolytic polarized capacitors that have larger capacitance than the ceramic ones, but they are still of high quality. Not as high as ceramic, but still quite good. Their sizes are in the same manner as in case of resistors. So let's say that one is 320 times 160 mils, and this is the height. Some manufacturers are denoting the sizes with the letters, and these are different according to the manufacturer. The positive terminal is actually denoted by a dash. It's just the opposite as in case of diodes or electrolytic capacitors. So be very careful if you are soldering or working with the tantalum capacitor. The dash is denoting the positive terminal. The values are actually more or less similar. So 47 10 times to 6 picofarads, which is actually 47 microfarads. And the letter is denoting the voltage, usually, but not always. So yeah, still have to be careful. Depends on the manufacturer. What about diodes? The SMT diodes are in two main packages, the SOD and MILF. The dash is actually denoting the cathode. So the current flows, forward current flows here in this direction. Or here, or there, or there. Okay. Anode, cathode. Right. And so on. What about transistor? Well, small outline transistors are the main, I would say, part is for low current, low power transistors, but there are some small outline transistor cases that also have a fourth terminal for cooling. Usually that one is connected to the middle pin here, and it's collector or drain, and it's intended for cooling on the PCB. All right, so here some of the small outline transistors have more than 3 terminals, like that one, which has 5, or even you can find 6 terminal small outline transistor. In such cases you can find maybe 2 transistors or an integrated circuit like microcontroller or A to D converter can be found, or some sensor. The other type of the SMT transistor is discrete package, DPAC, and they are intended for high power transistors or some integrated circuit as well, like for example linear voltage regulators are in this. Okay, the pin numbering always starts with the positive terminal in case when the 2 terminals are used, or if there are more than 2, then you always start on the bottom left and then go counterclockwise. What about the markings? Well, the markings on this on these cases are of course limited with space. So usually you find 1 letter, 2 letters, a number or similar. So you have to find these codes on different websites that are having all these in a database. And you can, let's say, if you search for 5D, you will find several same components with these 5D letters from different manufacturers, but you can also find something completely different. So you have to be careful. The integrated circuits in SMD form are basically I would say, found in form of small outline something. Well, small outline means just small dual inline chip. And small outline transistors can be thin, shrink, quarter size, very small, ultra very small, small, shrink, very, and so on. So yeah, they are running out of small words, and they are really small. The pitch, which is the distance between two adjacent pins, is going from 1.27 to 0.4 millimeters in the smallest case. Quad packages have terminals from all four sides, and yeah, you have also a lot of different versions. Some of them have accessible pins, and some of them don't, like QFN or LCC. These are all having pins directly hidden below the package. They are really hard to access with solder iron, and the smallest cases also have power pads which have to be soldered on the PCB. So soldering with a normal soldering iron is not possible here anymore, so we have to use hot air, reflow soldering, and other techniques which we will learn about. What about grid packages? We have two main grid packages called chip scale package and ball grid array. They all more or less have contacts on bottom side which are arranged in a form of a grid, and you use solder balls to solder them directly on the PCB. You can have two different versions. Either the chip is bonded with wires inside this package to this small PCB on the bottom, and then the solder balls are applied, and this would be then the whole package. Or you can use flip chip technology, when the contacts are directly on the surface and you flip it upside down, you put small solder balls here, and then a small PCB with bigger solder balls on bottom, and this is then as BGA in a bigger BGA, I would say. Well, chip scale package is actually even smaller than BGA, as you see here. Usually here the only 20% larger is the PCB with regards to the chip itself, and this is then the whole package. In both cases, in BGA or chip scale package, you actually have a small, very thin PCB for a holder that holds the die, the silicon die, and on the bottom side you have solder balls. These grid arrays have also different names, as I showed here, and again they are in a lot of different forms. What about pin numbering? Well, you have to find which is the bottom left, and usually the bottom left is marked with a certain mark, like for example here with this hole, or the left side is marked with this one, with this indentation. Usually the print is in a way that you see it correctly if the bottom left is directly on the bottom left. So the marking denotes the pin number 1, and then you go counterclockwise around. Well, finding pin 1, where is it? Here. Very easy. This is the marking of the left side, and the bottom side is grinded. So again, this is a sharp corner and this is grinded. Okay, this pin 1. Here, the pin 1 is here. It's marked. This is the bottom side. It's grinded here. So the pin number 1 is here. Here, the side is grinded, and here you see the line which denotes the left hand side. Again, this is pin number 1. Here, this is the marking, so pin number 1 is here, and then we go counting clockwise direction. Pin number is here, pin number 1. You see two markings, So we have to rely on the corner, which is chipped off here a little bit. See, sharp corners, and here we have round corner. Pin number 1. Here, pin number 1 is here. So the letter or the text orientation is not always the same. So here is pin number 1. And here, pin number 1 is here. Okay, what about the last part of this lecture, about special new techniques that are now used or have been used for some time already. The first is direct chip attach. So if you go back a little bit, I can show you here the BGAs are actually made of a direct chip attached to a small PCB that again has solder balls, and then it's all packed in a single package. Now, why would you use 2 PCBs if we already have one? Why do we have to take the extra one? So this is a direct chip attach technique. So this is our PCB, and we directly solder or glue the chip on that area, bond it, and then fill it with some epoxy sealant and protect it from the air. The flip chip technology flips the chip around, does not use any bonding wires, directly you solder it directly on the PCB and protect it, or even not. You can see a bare chip die on a, let's say on a Raspberry Pi, for example. You see small bare chips there. Okay, what about embedded passives? Well, this is the, on the top side you see the evolution through hole, surface mounted, the quad flat package, the BGAs, direct bare die chip attach, 3D technologies, which stacks chips one on top of each other. So we have several PCBs with different size of the integrated circuits stacked one on top of each other. And then we have embedded components. What are embedded components? Well, you can actually embed the passive components inside the stack, like here. Or even you can embed the whole chip inside the PCB stack. Can you imagine? By that, you really decrease the area used by these embedded components. Let me show you an example. So what you can have capacitors, resistors, coils inside. Well, embedded resistors are actually separate layer of some resistive material that is applied to the PCB directly between the tracks, and then it could be a part of the mid layer somewhere inside the stack. And by that you actually reduce a lot of area because you don't need wires here, and it's directly on the inner layer. But that, I would say, the tolerances, if not controlled by some laser trimming, are more or less in this range of plus minus 10%, which actually for quite a lot of resistors you would actually be surprised that you actually don't need less than 10%. Embedded capacitors. What you can do, you can actually use a very thin dielectric layer, and here you see two copper areas that are separated by this dielectric, and that forms a capacitor. You see here, if you then pattern these layers, you can actually get more capacitors connected with wires. Of course, for that you need buried wires or blind wires, which makes it more expensive, of course, but the area needed is much lower because, again, you form a capacitor somewhere inside the PCB. But also, what is even more important is that you can make a better capacitor in terms of series inductance. Here you see this capacitor can be good, but the length of the lines needed and number of wires needed to connect it to a certain point can make it much worse, because every connection means a series inductance, and this plays quite a big role here. So this embedded capacitor is much better. It works at much higher frequencies because its series parasitic inductance is lower. What about inductances? Well, you can make some spirals or solenoids with wires. You can make large solenoid with wires. You can make some meanders, and by that making a inductance formed of a single wire. By that you can reduce PCB a lot. First of all, what you can go from the single-sided to a double surface mounted SMT, and you reduce it a lot. But then putting all these passives inside makes PCB even smaller. And this is an example going from this PCB to that one using embedded passives, which reduces the area by 40%. And this is then a part of a small USB key. Passive components can be also embedded in the flexible circuits, like here, for example, capacitors. They are formed inside the layers. So what you have learned from this lecture, I hope that you learned that you are able now to identify the components that you find on the PCB. You have to determine its type, the value, and the arrangement of pins. You should be able to describe different types of embedded passives and list their main properties. What are they good for? And that's the literature. You can check it out. There are some links and there are some books. So that's all about the components I wanted to tell you about. There are several more components, of course, on the market, but these are the main ones. And getting some detailed information about each type of these components will be given later in this course, but not everything, of course. And it's up to you. When you will design the electronics, you will have to decide which component out of million different types you will choose. And it's not always just sort by price and take the cheapest one. It's much more than that. And I hope I showed you a little bit of this area as well, just to remind you that this is something to take care or to think about when you are designing the electronic PCB. So thank you for your attention.